So I just mentioned few of the ways to get that data. That is observation, experiments, census, maybe these spellings are not correct, interview and surveys like that. So once we get the data, and that data is called raw data. Okay? So once we obtain the raw data, then we want to know the information. That data is not a information, but we want to convert the data into information. What kind of information we want to get? The first information is about its central value. That is called central tendency. So to get the first information, which is far most important information, it is about the central value or central tendency, and it is also called averages. So there are three kinds of averages in IGCSE and O level. So these are the three central tendencies or averages which we encounter in our IGCSE mathematics: mean, mode, and median. There is second kind. There is also another kind of. There is another information in which we are interested, and that is called the spread. So the second information in which we are interested from the raw data is called spread of the data. So I will explain you with an example why we are interested in the spread of the data and why we are interested in the central value of the data. So these are the few methodologies or methods finding the spread of a data. The one is called range, variance, and standard deviation. But in our syllabus, we have only range. We study range only in O level and IGSE. Rest two are we discuss them in A levels. Okay. Achha, so first of all, let me tell you why we call these averages as a central value, central tendency. Because if we have a large data, if you are moving, if you are going on a journey and you are moving in a car with different speeds, so if you observe the data of your speed, you will mostly feel, you will check that the average of your car will be it will be exactly or approximately in the center of the data. Normally in our daily life, we are not sure whether we are using mode or median. We frequently call this mean as the average, but actually these three are the averages. Okay? In our real life, we just think that only mean is the average and this is the average. The basically mean is a type of average. Okay, but if you take a data in a number, for example, you are taking observation 30, 40, 50 observation, you will observe that the mean will be exactly or approximately in the center of the data. So when you have a large number of data, for example, you have 30, 40, 50 observation, all these three will be approximately in the middle of the data. So that's why we call them central tendency. The most favorite one is mean. We use mean frequently if all the observations come into the center of the data. In that case, we use mean. We prefer mean then. Why we prefer mean? The reason is that mean has a mathematical formula. The rest of the two, they don't have the formula. So we prefer that methodology in which we use mathematics. Second thing for preferring this mean is that mean uses all the values of the data. What does mean do? You just add all the values, then divide the number of values, you get the mean. But in mode, you just take only those values which comes frequently, whereas you don't consider the rest of the values. So that's why mode does not take all the values of the data. And the median only consider the central values. It never bother about the rest of the values. So that's why mean is a more preferable, because it uses the mathematical formula, and plus it uses all the values in the data. So if there is no problem in the data, all the three observation comes into the data center of the data, then mean is the most preferable average. But there are some circumstances in which we don't use mean, we use mode. And that mode is used in those cases in which we use a popularity, we check the popularity. For example, there are three candidates who are contesting election. So we don't add all the votes and then divide by 3 and then select that candidate. And in that case, we select that candidate who got more votes. So we use mode in that case. Mean and median will be meaningless in that case. Okay? For example, there's a shop in which shoes are being sold, and you want to know which shoe was sold in a large number of quantity. So you what you do, you just keep on recording the shoe number. So every time you sell the shoe, so at the end you check which shoe has sold most of the time. That will be the mode. Suppose shoe number 7 has sold most of the time. So the shoe number 7 is the mode of the data. So we use mode in that case, not the mean and the median. Median we don't prefer median until unless there is a problem with mean. If mean has some kind of problem that it does not comes into the center of the data, only in that case we prefer median. Otherwise we don't prefer median at all. So when mean get problem, let me give you an example. So if suppose you have this data 1 2 3, here the gap between the data is equal. There is a gap of 1 between each observation of the data. So the mean is exactly in the center of the data. Suppose now we have this data 1 2 and 12. Now you can see here the gap between the data is not same. The gap between 1 and 2 is 1, and the gap between 2 and 12 is 10. So now let's find the average here. So according to the definition, average should be in the center of the data. Average should be 2 here, but let's calculate the average here. 12 plus 2 is 14, and 14 plus 1 is 15. 15 divided by 3 is 5. So 5. So what happened? Now the average is not exactly in the center of the data. It is because this big value, this large value, which is called extreme values here, this extreme value has pulled the average towards itself. Because extreme value is not on the right hand side, so this average is pulled by the large value toward the right side. So now the average is not in the center of the data. So in this case, we don't use mean, we will prefer median, because still the 2 is in the middle of the data and median is 2 here, so we will use median in that case. So these averages are called representative data. Why? If you take an average of your class, so class of grade 10, so the average will be average age will be 16 years. What does it mean? It means that some of the student may be 16, if the average is 16, so some of the student may be 15 years, some of may be more than 16 years. So but the most of the student will be close to the 16 years. So from the average we get the information that most of the student they will be close to the 16 years. So that's why average is called representative of the data. But suppose there is a one big number there. So what will happen? That big number pull the average towards itself, and now that average will not represent the true picture of the data. Now let me tell you about the spread, little bit about the spread. Why spread is so important? Why spread is important? Let me give you an example. The first data is 1 2 3. So can you tell me what is the average of this data? No, you can observe the mean of the two data. So the first data has mean 2 and the second data also has mean 2 as well. So look here, the range of this one is 2 and the range of the second one is 4, and range is maximum minus minimum. So 3 minus 1 is 2 and 4 minus 0 is 4. Now you can observe there are two different types of data. Both have same average, but range is different. Spread is different. If these are the marks of a test in the class 1, the second class 1, so they both have the average marks too, but which class is better? So these are two classes, both have the same average. So if the average of one class is higher than the average of the second class, then that class is considered to be a good class whose average is greater than the second one. But right now both have the same averages. So on the basis of the range, we can say that the class second has inconsistent performance. Why inconsistent? Because some of the students have extraordinary performance and some are performing very badly. Where in the class 1 they are performing consistently Why consistently? Because on the average, most of the performance of the most of the students are approximately equally same, because there is no much spread from the performance is not much, it is not, the range of the performance is not much too away from the mean. They are not far from the mean, they are very close to the mean too. But here in the second class, some of the student most of the student some of the students are far from the mean, so their performance, some of are very good and some are very bad. So in class 2 the performance is not consistent, inconsistent performance, whereas in class 1 the performance is very much consistent. The students are equal in caliber, but in class 2 all the students are not in caliber. So it is difficult to teach class number 2. Teacher will find difficulty to teach class number 2 because some are so good, some are so bad, some are average. But here in class 1 teacher will teacher will feel comfortable while teaching in the class, because most of the students, they are equal in caliber here. So if you want to go for prediction of the data, your prediction will be good for the first one, because the range is not very large here. Once we have data, what we do, we convert their data into a table form. If the raw data is very large one, so there are two kinds of frequency tables. So there are two types of frequency table. One is called without interval frequency table, and second is called interval frequency table. So let me give you an example of each one. Okay student, you can observe right now here. So this is the data of 40 student of the class test, math class test. Total score was 10. So out of 10, these 40 students got these kind of marks, and these are 40 observation, and we have converted this 40 observation in this frequency table. Here you can see the score is not in the shape of interval. Score is not in the interval form. So this is non-interval frequency table. So sometimes the observations, observation are of different type of the numbers, and maybe sometimes the observation are in the decimal form. For example, this table shows the approximate length in millimeter of 40 leaves taken from the different plants of the certain species. So sometimes the number of information are different, lot of different information, and sometimes the information are in the decimal also. So in that case we make this kind of table, and we use class intervals. For example, 25 to 30, 30 to 35, like this. These are called class interval, and this table is known as class interval frequency distribution. So these are two kinds of frequency table which we use in our statistics when the raw data is large. So with the help of these frequency table, we draw histograms, we draw these bar charts, and then with the help of this frequency table, we also draw this cumulative frequency curve, from which we get interquartile range and median and percentile and decile, etc.